We've got one last index law to look at, and that's the negative index law. So, negative index law says that if A is in a pronumeral, just A is in letter, if A is a non-zero integer, then A to the power of negative n equals 1 over A to the power of n. So that means if I had, let's say, 3 to the power of negative 2, I would just rewrite that as 1 over 3 to the power of positive 2. And to simplify that further, that's the same as 1 over 9. So why does that work? Well, we could go through an example here. What if I had, let's say, 2 to the power of 3 divided by 2 to the power of 5. Now you know from your other index laws that that would equal 2 to the power of 3 take 5, which is equal to 2 to the power of negative 2. So I've got a negative power there. If I look at what I've got here over on the left, 2 to the power of 3 is 8, 2 to the power of 5 is 32. If I simplify that, that's equal to 1 quarter. Back to this one, if I follow this rule over here, a negative 2 means that's the same as 1 over 2 squared, which is equal to 1 quarter. So you can see there I've shown that those are equal, and this will work for anything. So that's all very good if it's a really simple thing, like even b to the power of negative 6. That would be equal to 1 over b to the power of 6. Get that negative power and pop it on the bottom. The next thing we can do is combine it with other rules. On the previous screen, it said that if you have something to a negative power, it's the same as the reciprocal to a positive power. So, for example, when it was, what was it, a to the power of negative 1, it becomes 1 over a to the power of 1. You can see how it gets switched around. So if you see a fraction inside a bracket with a negative outside it, what you can do, if it's a negative 1, it's really just going to be 4 over 1 to the power of 1. Anything to the power of 1 is just itself. 4 over 1 is just 4, so that's going to be equal to 4. Looking at this one here, we need to get the reciprocal and change that from a negative power to a positive power. So instead of being 2 over 3, it's going to be 3 over 2 to the power of 2. And what do we know about what to do if there's brackets with the power outside? That's right, we need to put that power on everything inside. So it becomes 3 squared over 2 squared, which is 9 quarters. And you could leave it as an improper fraction like that, or you could change it to a mixed number. Just check to see what the back of the book is doing, and just keep going that way. There are advantages to doing both things, by the way, when you've got an answer, and this applies across maths. If you have got an improper fraction like that, it's easy to work with other fractions for adding and multiplying, dividing, subtracting, all that sort of thing, than it is with mixed numbers. You'd have to convert it back anyway. But if you wanted to know how big a number is, it's easy to tell if you change it with mixed numbers. 9 quarters might not mean a lot to you, but 2 1/4, which is what that is equal to, might make more sense. Over here, I've got a negative power here. So 2 to the power of x to the power of negative 2, that's going to be the same as 1 over 2x to the power of positive 2. And again, I've got a power outside a set of brackets. I've got to apply that power to both of those things. So that's going to be equal to 1 over 2 squared times x squared, which is equal to 1 over 4x squared. And that's my answer there. It's all I can do for that. Right, are there any other examples I can give you? I guess what I should do is I should point out the difference between this kind of expression here and this one over here. Obviously there's a bracket, that makes a bit of a difference, doesn't it? What does the bracket mean? the bracket means that that -3 applies to everything there. So I would rewrite that as 1 over xy to the power of 3, which equals, oops, with the bracket, which is 1 over x cubed y cubed. But what about this one here? There's no bracket. So what does that -3 apply to? It doesn't apply to that x. That x is just a single solitary x to the power of 1. That y is to the power of -3. So when it comes time to to put that to a positive power, I'm going to rewrite this like this. X over y to the power of 3. And to show how I get there, I'm just going to sort of split it apart a bit. That x to the power of 1 and that y to the power of -3, I could rewrite that as x to the power of 1 times y to the power of -3. And just giving it that bit of separation shows you how we get to here, I think. Because x to the power of 1, right, that's just x. This here is going to be 1 over y cubed. And how do you multiply a whole number by a fraction? Well, and then my camera ran out of battery. So I was about to say, if you want to multiply a whole number by a fraction, put the whole number over 1 to make it a fraction. When you multiply two fractions together, like I've got here, x times 1 is going to give me x times 1 on the top, and on the bottom we'll have 1 times y to the power of 3. And my result from this is going to be x on top and y to the power of 3 on the bottom. So whenever you see some pronumerals in a row here, if they have a positive power on them, or if they have no power, which means they do have a positive 1, they are going to end up on the top of your answer. If they have a negative power on there, they're going to end up on the bottom and you'll change them to a positive. So if I did another quick example, if I had a times b to the power of -2 times x to the power of 3, what's going to happen with those? The a and the x cubed are going to stay on top. And the b to the power of -2 is going to become b squared on the bottom there, okay? And like I showed you here, you separate them all out, that's how it's all going to work out, but there's a little bit of a shortcut for you if you come across that situation.